Alright, how does pressure change when a container of fixed volume is heated? Well, let's find out. In this question, it says a 355 milliliter container contains 0.4 atmospheres of pressure at 300 Kelvin. What's the pressure at 600 Kelvin? Well, when pressure, volume, or temperature change in a question, I like to use this equation. This is basically the ideal gas law. PV equals nRT. Now, if I take PV and divide it by nRT, I'm going to get 1 because PV equals nRT, so we're dividing something by itself. The point is that the initial pressure times the initial volume divided by the initial number of moles times R times the initial pressure or the initial temperature. The ratio still holds for the second conditions of pressure, volume, and temperature. So start with this and cross out anything that stays constant on both sides. This is a can. It's not going to let gas in and out. So that means that the number of moles stays constant. R is the gas constant. It's the same on both sides of the equation. We can cancel it out. It's a can. It's probably not going to expand and contract. So that means volume is the same on the left and right hand sides of this equation. And what you'll find is that P1 over T1 equals P2 over T2. Now this has some kind of special name. It's like Boyle's law or Charles's law. I'm going to be honest, I never memorized those. I just always figured it out this way. The first pressure, 0.4 atmospheres. The first temperature, 300 K. The new pressure is what we're solving for, and the new temperature is 600 K. How do you solve for the new pressure? I have to undo division by 600. So my new pressure is 0.4 divided by 300 times 600. Notice how division became multiplication. And when you do that on your calculator, you get 0.8 atmospheres. Piece of cake. Just use the initial equation and cancel out the variables that stay constant from one to the other. I want to show you a second example if there's a change in volume when something's heated. This balloon is going to stay at constant volume, 1 atmosphere. It starts out with a volume of half a liter at 250 K. What's the volume at 750 K? Well, it's a balloon. It doesn't let stuff in and out, so the number of moles is the same. R is a constant. It'll always be the same on both sides. And I've told you the pressure is going to be the same. So that means V1 over T1 equals V2 over T2. So let's fill in the numbers that we know and solve for what we want. The initial volume is 0.5 liters. The initial temperature is 250 K. The new volume is what we're solving for, and the new temperature is 750 K. How do you solve for V2? Well, you undo division by multiplying. So it's 0.5 liters divided by 250 K, and you multiply by 750 K. When you do that on your calculator, you end up with 1.5 liters. So tripling your temperature in Kelvin also leads to a tripling of the volume. The lesson is you can always use this initial equation and cross out the variables that are constant from your initial set of conditions to the final set of conditions. Then just plug in what you know and solve for what you don't. Best of luck.